Okay, so in this video I'm going to show you how to do a dihybrid Punnett square. It's quite a bit different from the monohybrid Punnett square, so but we're on the same page. We're on pages Inheritance 3 and 4. It's at the bottom all the way across. And so over here by dihybrid, just right, it's a mixture of two genes. So that's what that di or two means. The hybrid is still, it's a mixture of two parents, and the di is that we're looking at the alleles of two different genes. So I've already started writing, so I'm just going to kind of reveal a little bit at a time. Again, pause this as you need to, rewind it if you need another explanation. Okay, so what we're doing here is we are crossing two genes alleles of two parents. So, for instance, in our examples, we're going to be looking at plant height and pod color, so the pods that hold the seeds. And so this parent is heterozygous for plant height, but it's still tall. And this parent is also green, but it's heterozygous green because green is our dominant allele. And it's going to be crossed with a short green plant. Okay? Now there are a couple of major differences at the beginning, and well, I guess it's just different all the way through. You're still looking at how can we get, what all kind of offspring can we get here, but first thing you have to do is find all of the possible combinations of alleles of each parent. And there's two ways to do this. So it's important that you find all the combinations of height and pod color that each parent can give to their offspring. So you can do this in one of two ways. You can foil, and if you'll remember from like Algebra 1, when you foil like two parentheses, they're right beside each other, it means first, outside, inside, last. I should have written that down. So it means first, outside, inside, last. Okay, sorry, I know that's super duper tiny, but that's what FOIL stands for. So what you're doing is if you're looking at, let's say, this parent, you're going to look at the first allele of each gene. Well, this first allele is big T, and that first allele is big G. So that's what you would write down right there. Okay? And then the outside, you're looking at the two outside letters of that four-letter parent. So you got the big T and the little g. And then inside, the two inside letters of the four letters are little t, big G. Now this is the example of it's okay that that little t is for that recessive t is in front of that dominant G because they're two different genes. They don't have anything to do with each other. We're just looking at them at the same time. So you need to keep your t's first because that's how they're listed in your parent. Okay, so just keep your t's first even though that's recessive. And then last just means the last allele of each of those genes. So that's little t, little g. Okay, so you can foil it, or you can just do a monohybrid cross, breaking up using these two sets of alleles as what you're going to put around your square. So you could just make a little monohybrid cross square and separate out your t's and separate out your g's, and then keep your t's first inside the square. And you get the exact same information. Okay, so either one of these is going to give you the exact same answers, but you have to keep your t's first just because they're listed first in your parents. Okay, so you have to do that first. That's very, very important. So once you do that, then you know all of the possibilities of what you're going to put over here on your square. Okay, so a couple more rules real quick. Always couple of things you're going to always do. Always keep alleles in the order of the parent generation. Or the P generation. Okay? So always keep it in the order of those parents. Also, always keep alleles for each trait together. You don't break the T's apart. You don't like put T, G, T, G. You don't do that. You keep the T's together, you keep the G's together. And you keep the dominant allele within a trait first. Okay, so within the same letter, you keep that dominant allele first. So, let me give you a couple of correct examples. Let's make an apostrophe S. Okay, a few correct examples would be like little t, big G. We're keeping those little t's in front of those big G's because they're separate genes. They don't have anything to do with each other. We're just observing them at the same time, and they're in the order of that parent generation. You would also do like big T, little g. Keep the T's first. Okay, so just those are a few examples of how you do it correctly. And I know this is odd, but I do want to give you some wrong examples, because, you know, over the years I kind of see a couple of trends of things that students want to do, and I don't want you to do these things. If you have something like this heterozygous parent, you don't do something like that. Okay, you do not put your dominants first and then your recessives and break those letters up. You keep the T's together, you keep the G's together. You also don't just switch them up just for fun. Okay, you keep those T's first if they're listed like that in the parent generation. What else? You don't ever just put the recessive of the same letter first. You don't do that. Okay, this is definitely wrong. It's wrong in monohybrid crosses. You do not do that. Okay, and so one more important note is use a system. I told y'all in monohybrid crosses, it's important to have a system. It's not as important in those, but once you get into here, you need to use a system on the genotypes and phenotypes to keep track. Okay, I love doing these, but if you don't, do order, have an order that you do your stuff in, if you don't kind of keep it neat and have a system that you use, you will mess up. And it's not because you don't know what you're doing, it's because you just missed, you just kind of mess up, okay? So, with all of that said, I want to move over here, and this is an old example that I created, but I didn't want to use B because we were using like human traits, and human traits don't work this simply. So we're changing the B basically to G, and we're going to use tall plant, short plant, green pod, and yellow pod. And I had a student that asked, why do we have a G for yellow pod? Well, that's because you keep using the same letter of, usually it's the first letter of that dominant trait. Like T is for tall and G is for green. It's not always the case, but that's just kind of how that works a lot. So this is another way, that I'm showing you kind of how this works. Once you find, do the very first thing that we have to do, find all possible combinations of both parents. So we did that here. I did it in two ways. I foiled it, so first, outside, inside, last. And then I also did the Punnett square, so it shows you that that's the same thing. Once you find these, and I'm going to use a marker to kind of show you what I did with them. Once you find, ooh, that's darker than I planned, all of these, then you put them across here. Okay? And then, when you find, let's see if I can find one that's actually light. The second parent information, I don't care if you foil it or use that monohybrid cross. Once you find that second parent's information, you put it down here, okay? Please be careful not to just take these and write big T, big B, little b. Happens every single year. You have to foil first, okay? So please don't forget that part. Very, very important. Okay, so open up your open up your foldable. And we're going to start off with the hardest one we can do. Now we're using T's and B's, and the very hardest one that you can have is where both parents, no, I'm sorry, we're using T's and G's, where both parents are heterozygous for both traits. That gives you the most possible combinations. So what I'm going to do is I'm going to foil this parent, and then I'm going to monohybrid cross that parent. Now, they're the same, so obviously my answers are going to be the same, but that's not always the case. So with this parent, we're going to foil to get what we put across here, okay? Because remember, the point of this is to find all possible combinations of height and pod color that we can give to the offspring. So first is these two, so big T, big G. Outside are my two outside letters, so big T, little g. Inside are my two inside letters. You can keep that little t first because it has nothing to do with that G, okay? And then last are the last letters of those two groupings. And then I take that information and I put it across here. Okay? And then to get the exact same thing, you can either foil the other parent, whichever one you're more comfortable with, or you can monohybrid cross. So I don't care which one of these you use, but you just need to make sure you're comfortable with it. So you take those T's and spread them out. Take those G's and spread them out. Keep T first inside the squares. And then take that information and spread it out right here like that. So that is your two parent, all of the genes that they can give to their children possibilities. Okay? So now when you go into the squares, you keep the T's together and you keep the G's together, and then within those letters you keep the dominant one first. So inside this TG combo is going to go all the way down. These are going to go all the way down, and then these are going to go all the way across, okay? So inside this square, I'm going to have these two sets of alleles. So I'm going to put my two T's together, and then I'll look at my G's, and I put them together. That just happens to be homozygous dominant for both traits. So then I scoot over to the next one, and I look at my T's. I have two dominant T's, and I look at my G's. I have a dominant one, and I have a recessive one, so I'll keep that dominant one first. So then I move over to the next one. I have a dominant and a recessive T, so I'll make sure I put the dominant one first. And then I have two dominant G's. Okay, so you just do that all the way across. Dominant, recessive, dominant, recessive. Now I want to show you like this square right here. I have a recessive T and a dominant G and a recessive T and a dominant G. So I keep those recessive T's first, and I put both my dominant G's like that, okay? So I'm going to just work through this really fast. I would suggest that you pause the video and work through it, probably using a pencil, and then start my video and then watch me finish it, okay? No, ma'am. Okay, that's fine. That is absolutely fine. I wish I could pause it, but I can't. Oops, I think I just messed up. No, I did not. Okay, so this should be where you have all of your T's together and all of your G's together. And so you just want to make sure that you have exactly what I have. Okay? Now, for the genotypes, this is where you want to have a system in place. You want to have a way that you kind of keep up with what you're doing here. Okay? So remember that the genotypes are the alleles of the offspring. How many possible allele combinations could these offspring have from these two plant parents? Okay? So I start in the top left corner and I write down my first genotype. And I count how many exactly like that do I have? Well, there's only one and there's 16 squares. So I put a little check or something in there. Then I move to the next one, homozygous dominant, heterozygous. How many do I have? I've got 1, 2. That's 2 out of 16, which reduces to 1/8. So I go to the next one, heterozygous, homozygous dominant. I have 1, 2. So 2 out of 16 reduced to 1/8. Don't reduce in your head. Go ahead and write that out of 16 so that we can check at the end and make sure that we've counted all of our squares correctly. Then I've got heterozygous for both traits. I have 1, 2, 3, 4. So 4 out of 16, which reduces to 1/4. So then I've finished that row, I go to my next row. Well, I've already counted that, so I don't count it again. I go to this one. This has not been counted. Homozygous dominant, homozygous recessive. I have 1, and that's it. So 1 out of 16. I've already counted that one. So heterozygous, homozygous recessive. I have 1, 2. 2 out of 16. Move to my next row. Counted that one already, counted that one already. Homozygous recessive, homozygous dominant. I have 1 of those. Then homozygous recessive, heterozygous. I have 2 of those. And then I've counted everything except this one, homozygous recessive for both, and that's 1 out of 16. Okay? So you will have to go a lot slower. I've done this one, like about a gazillion times, and that's a lot. So anyway, I kind of knew where everything was, but you need to go slower. Really make sure that you get your genotypes right, and then go through and count your numerators and make sure that you have 16. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's just another way to double check that I've counted all of my squares, okay? Now, the phenotype, if you'll remember, is the physical. So once I've done this part right and I feel secure that this is right, I don't look at my square again because that's just kind of like too much. It's a little bit overstimulating to me. So I just stick to looking at my genotypes for this part. So if you remember, the phenotype is the physical, or what you actually end up seeing because of these genes. Let me back off a little bit because my hand is all right there in it. Okay, so this one, and right now we're still saying that there's no blending. Okay, it's like if the dominant's there, it totally overpowers the recessive. So this one's going to be tall and green. So what I'm going to do is I'm going to create like a triangle for everything that is tall and green. Okay, and I'm going to say this was my triangle stuff. This one's tall and green, so I'm just going to put a triangle. Those are going to be tall and green. Those are tall and green. Those are tall, but those are yellow. Tall, yellow, short, short, yellow. So all of my triangles, and I need to add them up. Well, it's not 4 because if you don't reduce in your head, then you have how many squares ended up being tall and green. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 16 squares over here in my Punnett square were tall and green. Okay? So then I go to my next one that I haven't counted yet. This was tall and yellow. So I'm just going to do like a dot. So a dot is going to be tall and yellow. So I have that one's tall and yellow. That is tall and yellow. That's not tall, not tall, not tall. So it's not 2, it's 1, 2, 3. So 3 out of 16 are tall yellow. So then I go to the next one that's not counted. It's this one. I'm just going to do a dash. These are short and green. Short and green. Okay, so that one's short and green, that one's short and green. That is not. It's short but yellow. So again, it's not 2, it's 1, 2, 3. So 3 out of 16. And then the last one, you know, you could go ahead and do something else. We only have one here, but I'm going to go ahead and do something else because sometimes you might have more than one. Is short and yellow. And there's only one. There's only one right there. So again, even if none of these reduce, but if they did, then you don't reduce them until you write down the over 16 so that you can count to make sure you've counted all your squares. So you've got 9, 10, 11, 12, 13, 14, 15, 16. Okay? And then you know you're right. Now, I'll give you a hint. If you ever have two parents who are both heterozygous for both traits, you will always get a 9 to 3 to 3 to 1 ratio. You will always be 9 to 3 to 3 to 1 of dominant, 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 recessive, recessive, dominant, recessive, recessive. Okay, so that's, you don't have to remember that, but you know, that's just a way to kind of see that you did it correctly. Now I do have another video where I'm showing you this again. It's using different letters, I think, or whatever, but it's on YouTube. So if you need any more help, just let me know. But again, this is the hardest one you can do. So that wasn't that bad. So just be neat with your work and keep up with it when you're doing your genotypes and phenotypes.